Kennedy.
I'm Hezekiah J. Burton.
And we are SLAG team. Today we'll be doing a failure analysis of Logistics Inc.'s Bad Boy, which is a pneumatic launcher. Is it a bundle of hope or a bundle of failure?
We will see today. Some background. The problem that Logistics Incorporated wanted to solve was the event of a nuclear reactor or weapon explosion. Of course, the immediate threat would be the massive amounts of radiation emitted from these devices, and they're very dangerous to human health that can result in death. People within 20 miles are usually the people that can't get the help since the levels of radiation are too high to risk anybody going in. So this is the problem area that people are Logistics Incorporated are targeting. People within 20 miles of a nuclear incident. Here's a Fukushima accident, Japan, 2011.
This is a map of Europe and showing the radiation spread of the Chernobyl disaster.
As you can see, it's very extensive, covering the whole European continent. 3 Mile Island accident. It was in 1979, Pennsylvania. You can see that there is no life within the vicinity of the explosion.
And this is the proposal of Logistics Inc., the giant pneumatic launcher. This is a quote from the website. Simply put, a pneumatic launcher or air cannon is a device that uses air to launch objects. We felt this was the correct design choice due to its weight, cost effectiveness, and durability. The distance that radioactive zones require launching from is daunting, but possible with the right size launcher and correct amount of air pressure. The launcher is commonly built out of PVC pipe, which serves as the body and chamber of the launcher. A valve will be connected at a point on the body of the launcher, and an air compression chamber will supply the force necessary to propel the supplies. A cap will be connected on the end of the launcher opposite the chamber.
This is a picture of the bad boy, as described from the proposal.
And this is a picture of Isaiah J. Burton, not to be confused with Hezekiah J. Burton.
Not related.
He is the CEO, CFO, and COO of Logistics Incorporated, holding a model prototype of the bundle of hope.
The supplies that will be contained in the bundle of hope will be enough for a family of 4 for 3 days. As you can see, the basic necessities of food, water, radiation tablets, bandaging, clothes, flashlights, batteries, basic things needed to survive are all included in this bundle.
And here are the dimensions and specifications of the actual launcher.
Our analysis, pros versus cons. We'll start off with the pros first. It's very environmentally friendly. The absence of the use of explosives to propel the package prevents the emission of harmful pollution. The material is very cheap, as it's made out of PVC. It abolishes the use of manpower in highly radioactive zones, which was the purpose of building it. It was to eliminate the use of manpower. And its 20-mile range gives product efficiency at delivering supplies at distances.
Here's some of the cons of the bad boy. The size that you need to reach a 20-mile radius is impractical. It would actually be almost 4,000 feet long. The methods such as drones and helicopter drops.
We can cut that out.
Yeah. Accomplish the same thing and are more mobile than the cannon. The necessary speed would be better reached by explosives. In fact, the speed would actually be Mach 2. Necessary speed of packages reaches dangerous levels on impact. 113 pounds hurling towards the ground at twice the speed of sound is very dangerous.
You better duck. Conclusion, the bad boy was creative and would have solved the severe problem of getting relief to radioactive areas. But it had some major issues. The design of a gigantic cannon was very inefficient, and supplies could have easily been delivered by an aerial drone. Logistics made their product with passion and creativity, but they made a fatal error in that they designed their product before making sure it was practical. Logistics was thinking of the solution before addressing the actual problem.
Logistics had made a common mistake that many engineers make. They had the classic hammer and nail problem solution mentality. They came into a situation with nothing but a hammer and thinking every problem was a nail. Exploring no other options or tools, logistics attacked the problem with the hammer, the giant pneumatic launcher, head on. Unfortunately, the radiation problem was not immune. Good intentions failed practically.
The end, and that's it for our presentation.